Hi everyone and welcome. Today I want to talk about something I keep seeing across organizations. ML projects that look successful, the demo works, accuracy is high, maybe even a KPI moves, but the expected business outcome never takes the planned shape. This is the early 2026 edition and it's done on purpose. The AI hype has cooled a little bit. Many teams have already shipped pilots, co-pilots, dashboards, and prototypes. What remains is the enterprise reality. Most initiatives fail quietly, not because the model is bad, but because AI is built and operated like traditional software. So if you've ever seen AI project get stuck in pilot mode, get stopped at production gates, or slowly degrade after launch, this talk is just for you. My name is Dr. Andrei Holtz. My Ph.D. is in applied mathematics, and my research was in predicting asteroid impacts. That background trained me to think in uncertainty and constraints. For the last more than 12 years, I've worked in enterprise AI, building and shipping systems from concept to production, classical machine learning, computer vision, and more recently, GenAI, including RAGs and agentic workflows, in environments with strict requirements in security, compliance, and operations. And the reason I am doing this talk is simple. I've watched teams repeatedly fall into the same traps. My goal is to share a practical roadmap to avoid them and to help you build enterprise AI that is actually practical for business and leads to predictable and measurable outcomes. Traditionally, IT project failed for three reasons. The solid boxes you see here. Business objectives. Well, we solved the wrong problem or couldn't prove ROI. Technical challenges. The infrastructure wasn't scalable or the data was messy. Human factors. The team lacked skills or the users refused to adopt the tool. If this were a standard software talk, we would stop here. But look at the dotted box on the right, AI factors. This represents the shift from deterministic to probabilistic systems. AI introduces risks we never had to manage before: hallucinations, model drift, non deterministic outputs, and massive ethical liability. The core message for this presentation is that you cannot manage AI factors using the old playbooks from the first three boxes. When you combine human confusion with the probabilistic systems, you get a unique type of failure. Let's dig into what that looks like in practice. And let's start with enterprises. Most enterprises aren't in one place. Some teams run experiments, some ship a pinpoint solution in one function. Fewer teams embed AI into core workflows, and very few build a reusable platform capability. The problem is leadership often collapses all that into one label: we are doing AI. And this misalignment actually makes enterprise delivery hard and inefficient. Now, look at this picture. This is what doing AI really means inside a company. You have silos, different stakeholders, different definition of success, and even basic terms like copilot agent or automation mean different things to different groups. That's where drift starts and the project focus blurs. Then you hit IT and security. They're responsible for the potential risks and approval processes. And if you don't highlight these constraints early, the project won't fail loudly, but it gets scoped down or blocked at the gate. And all along, the enterprise keeps asking the same two very questions you see here: cost and value. If you cannot connect the model to real workflows and accountable ownership, value stays hypothetical. So, enterprise AI is not only a modeling problem, it's a coordination challenge across silos, stakeholders, security, and workflow change. We often treat machine learning as a purely technical problem. We have the data, let us train the model. But this slide is the reality check. In an enterprise, there are four main challenges: people and processes, technical foundation, business value, and risk and control. The first one is people and processes. Without clear ownership and a real workflow change, even a great model becomes a side dashboard. If nobody owns the outcome and the process stays the same, impact stays theoretical. Technical foundation, especially data access. It's not just like GPUs or infrastructure. The most common blocker here is getting the right data out of legacy systems into something you can operate reliably. Business value. This is the POC factory. Teams optimize a local KPI like accuracy, but never answer the real question: which business decision changes and how do we measure that change? That's KPI theater instead of ROI. Risk and control. Enterprises don't just ship solutions. You need compliance, auditability, and security. And if you ignore data leakage, explainability, or prompt injection, the project can work technically but still got stopped at the governance gate. And let's make this tangible with a simple analogy. Imagine we built a perfect robot chef that can cook the ideal steak every single time. The model works, the robot works. And yet, the restaurant still fails because the restaurant is a system. So let's dive into four pillars: people and processes. Well, nobody knows when to use the robot, who turns it on, who cleans it, and how the staff should change their routine in general. So the workflow stays the same and personnel mainly ignores the robot. Technical foundation. The ingredients are locked behind access of a robot. There is no socket for changing the robot in the kitchen, so the robot can't actually operate end to end. And business value. Robot makes steaks delicious and efficiently, but you have put it in a soup cafe and customers come mainly for soup. So the steak quality KPI goes up while revenue doesn't. And risk and control. The robot does not have a sanitary permit, and local sanitary inspectors shut the place down. And as the bottom line, the robot isn't bad. The restaurant just did not treat it properly. And that's the pattern for the whole talk. Most machine learning and AI initiatives fail operationally, not technically. This slide is a useful historical snapshot, but I want to be explicit here. It's a bit outdated. It reflects how we described ML projects before 2023. I'll use it as a baseline and move on quickly because the next slide captures the modern reality much better. This is where things get interesting. In classical software, we are used to release cycles. Version 1 leads to version 2, it's mostly linear. In classical machine learning, we moved to retraining cycles. Data drifts, performance drops, we retrain, we redeploy. That's a loop. But with GenAI and agents, we are in hardening cycles. These models are creative and non-deterministic. You don't just test them the way you would test classical software. You have to red team them, actively trying to trick the system into hallucinating, leaking sensitive content, misusing tools, or doing the wrong thing in a workflow. And you don't fix a GenAI bug once, you harden the system against it. Now look at the failure modes. In classical software, the system crashes. It fails loudly and with obvious consequences. In GenAI, the system often doesn't crash. It confidently gives you a wrong answer. And if it's an agent, failure can be silent and at the same time very expensive. Tool loops, repeated API calls, runway costs, or actions taken at scale that no one intended cause significant economic losses. So the delivery mindset changes and adapts. And the question becomes, how do we keep system behavior within acceptance bounds over time under real user behavior and real constraints? And this one is one of the most important slides in the deck. Are we solving the business problem? Or are we solving the right business problem? If the model hits the KPI, but the business decision doesn't change, we build a dashboard, not an AI capability. So I always ask, what decisions changes? Who owns that decision? What constraints are we removing? Because here is the enterprise trap. If your outputs don't change workflows, nothing changes. No workflow change, no impact. And one more strong statement, because it matters in 2026. If your first question by starting the project is which model should we use, GPT-5 or Gemini 3, you are likely to fail. The very first question that matters is what business decision are we automating and how we should measure it. And this slide illustrates a common failure pattern. Fancy terminology becomes a proxy for progress, replacing real work with new trends just for the sake of it. The AI is used as a proxy for progress. At the executive level, the language is strategic and high level. GenAI, agentic, autonomous, end-to-end. In the middle, these ideas transform into a project plan. And at the bottom, this project becomes whatever is feasible within the skills, tooling, data access, and risk appetite available. That translation step is where meaning gets replaced. And the gap gets filled with AI-shaped work, a demo, a dashboard, a bot. But constraints are not removed, and business processes are not improved. So the system works, KPIs move a bit, but the business outcome doesn't change. This is how enterprises burn months while staying at the same place, just with more artifacts. And a single AI project can be bounded. One team, one workflow, limited data, defined output. In this scenario, you can ship value even with imperfect foundations. Your goal is to show the value. Enterprise AI is different. Once the project meets multiple teams, customer-facing processes, regulated data, or meaningful business decisions, it stops being a feature and becomes a capability. Now, to maintain this project, company needs shared data practices, consistent evaluation, security approvals, monitoring and incident responses, clear ownership and update processes. Many initiatives stagnate only because companies try to scale a prototype mindset into production reality. And the failure modes are operational, not technical. And enterprise reality sets hard boundaries. Business goals can be clear and still incompatible with security constraints, compliance requirements, and how teams actually work. A common pattern: leadership wants broad AI capability, but data access is restricted or external model usage is blocked. Teams work around it, and the delivered product becomes something else entirely, weaker, narrower, and harder to operate. Alignment isn't just leadership and engineering. It must include security, legal, IT, operations, and the teams who operate with the system. If constraints aren't detected early, the project looks fine until production gates. There, this project will freeze and then fade away. I really like the metaphor for enterprise delivery. We often think of AI project as agile and lightning fast, powerful and progressive per se. But to the enterprise, we're just tiny figures on a new and shaky bridge. The enterprise is solid stone structure around us, massive, complex, built to stay where it is for ages. And if we ignore the weight of those walls, security, compliance, procurement, ownership, they will crush the project in no time. What about the delivery? Traditional delivery looks linear. We have requirements, we transform them into code, then we ship the code and provide maintenance. Logic is frozen in the code. Failures are normally easier to detect. AI delivery is circular. We have data, we train on this data, we deploy the model, we have new data, we retrain. The logic is fluid and input dependent. And that creates the day two problem. AI rarely crashes, it drifts. So the operational stack is not just uptime. You need observability, human validation loops, and up-to-date pipelines. And here is a line I like to use. Software changes on releases. Models change with reality. If you don't plan for that, you don't have AI product. You have a demo that will decay. What about QA? Classic QA tries to cover cases. But with AI, especially LLMs, the input-output space is too large. You cannot write a test case for every conversation. So the shift is deterministic to probabilistic. In the old world, we have unit tests like did the function return the expected value? The new world, machine learning and GenAI, needs evals. Does it meet targets and stay within policy? And constraint here, you cannot test every prompt. Solution to this is test representative cases and automate scoring. What AI QA requires: golden datasets, a curated library of hard cases and high-risk slices, metrics, correctness, hallucination rate, safety, policy, compliance, guardrails, defined policy boundaries describing when to refuse or escalate, regression harness, every update of model, prompt, reg, data, policies should go through the quality gates. And the main question for your release gate is, did it get worse on the cases that matter? And remember, a demo is an anecdote. QA is evidence. And if the project is shipped after only a few demos, it is still shipped without a proper QA. This approach puts the whole project at risk. Let's close the talk with a simple blueprint for success. And it's intentionally not model-centric. This slide has 3 columns: value, product, people. The first one, value. Start with the decision. The most expensive mistake is starting with what models do we need? The right first question is what decision or workflow are we changing? Then translate that into KPI, then into metrics and targets, so success is measurable, before we build anything. Second, product. Ship small, improve fast. Don't over-engineer upfront. Ship an MVP, then improve quality, safety, cost, latency, drift with the help of evals and monitoring and feedback loops. And remember, data and context are the fuel. If you don't have lineage, quality, and feedback loops from day one, you don't have a product, you have a demo. Third, people. Adoption is the job. If workflows don't change, nothing changes. Design for trust and process integration, and make ownership explicit. Who builds it, who pays for it, who operates it when it fails. And remember, if you cannot operate it, you don't own it. One last thing I want to share. I know we covered a lot of hard lessons today. Those lessons were learned the expensive way. Projects might look successful on paper, but got stuck at governance, drift after launch, or never changed the workflow. I distilled those scares from years of enterprise AI into one tool, the AI Project Health Scorecard. It's not a generic checklist. It's the one I personally use to audit projects. It contains the vital but uncomfortable questions on data, governance, ownership, and ROI before the project hits the wall. It's completely free. Link is in the description. You can easily download it, run through, and validate your current project. You can subscribe if you want. Next video is a practical walkthrough on using this scorecard. Another last thing, a few resources I've used in my own work and I can recommend. If you want to go deeper, these are excellent. Thank you for watching. If you take one idea from this talk, let it be this. Enterprise AI fails quietly when we confuse demos and KPIs with real decision change. If this talk was useful, please subscribe and let me know your opinion in the comments. And also, please share your experience. Which pitfall have you seen most often? Misalignment, constraints, ops decay, or QA gaps? I'm really excited to read your comments. And see you in next videos.